So let's go ahead and just look at that function review packet that I had you guys grab. All right. Can everyone see the board? Or do I need to cut the light out? Because I know my projector sucks. So if I need to cut the light out, please let me know now. Yes. Yeah. Okay. All right. Better? Okay. And guys, if there's ever something you can't see, or I know sometimes my handwriting can get janky, just ask me. You will not offend me. All right. All right. So let's look at question 1. This is simply an evaluation of a function. So whenever we're evaluating the function, that means that we're plugging in a number for either x or y, and either solving or just doing the calculation. All right. So it's saying that if f of x is equal to negative 2 x squared plus 3, and it wants us to find f of negative 3. Now, does anyone have a guess about what we would need to do? There's no wrong answers. Just take a shot in the dark. Right. So all we would do is take this negative 3 and plug it in to this x, and then just do PEMDAS. All right. So that's because if we write this as f of x, we're saying that if we replace this x with negative 3 on both ends, we will get an answer to that function. That's what it means to evaluate functions. So this is all evaluating. All right. So all I'm going to do is do negative 2 times negative 3 all squared plus 3. Now, middle school math 1 review. We're talking PEMDAS. What do I always have to do first? So order of operations. What do you do first? Parentheses. Now, those parentheses are more so for notation reasons. There's not actually an operation in them. So what's next? Exponents. So I do have an exponent here. What's negative 3 squared? Not negative 9. 9. So remember, it's negative 3 times negative 3. And a negative times a negative is a positive. So we're now going to have negative 2 times positive 9 plus 3. So now what do I do? Think PEMDAS. What comes next after exponents? Multiplication. Do I have any? Yeah. So I would do negative 2 times 9, which is negative 18. And then finally I add the 3. So what's my answer? Negative 15. Good. So rule of thumb is, if you have a negative added to a positive or a positive added to a negative, in other words, the signs are different, rule of thumb is subtract them, keep the sign of the bigger number. So 18 is bigger than 3, so 18 minus 3 is 15. Since the 18 is negative, we keep the negative sign. All right. Any questions on evaluating functions? So if you ever see something like this, you'd be surprised how many people get confused by this notation when reality it is the easiest thing in the world to do. All you got to do is plug that number in for x and put it in your calculator or just do a basic calculation. All right. So don't be thrown when you see f of some number. It's literally just plug in for x. That's all you got to do. So if you see this, plug in for x. All right. That's all you got to do. Any questions on number 1? All right. Let's look at number 2. Which of the following sets of coordinate pairs is not a relationship where y is a function of x? Now, you may or may not remember this, but does anyone remember what rule has to be met in order for a relation to be considered a function? You learned this back in Math 1, so you may or may not remember, that's okay. I'll give you guys a hint. It has something to do with the coordinates, so x, y. Okay, that's okay. Again, it's been a while. It's okay. So, in order for it to be a function, if it's a function, it means x values cannot repeat. So you cannot have you cannot have more than one of the same numerical x value. So for example, if the x value of your coordinates is 2, -3s, it's not a function. The y's can repeat all they want. All right, the y values can repeat all they want. If the x values repeat, it's not a function. All right. So all of these are sets of coordinates. So we're going to go through each of them and determine whether it's a function or not. So specifically for number 1, all we care about is the x values, and we're looking to see if they repeat or not. If they repeat, it's not a function. If they don't, it is a function. So answer choice 1, is that a function or not a function? What do you guys think? So take a minute, look at it. Thumbs up if you think it's a function, thumbs down if it's not. 3, 2, 1, go. So most of you got your thumbs up. You are correct. It is a function. If you look, all of these x values, -3, 0, 2, 5, all different numbers, they do not repeat. It must be a function. All right, so this is a function, so it's not part of our answer. What about number 2? So again, we're just strictly looking at the x values of those coordinates. Take a minute to look at it. Again, thumbs up if you think it is, thumbs down if you think it's not. In 3, 2, 1. Good, it's not a function. Can someone tell me why? Right, the -2s right here. These -2s, they repeat. They happen more than once. So because of that, it is not a function. Now, that would mean that this is our answer, but we're still going to check the other 2 just to make sure. So I'm not going to highlight the x values this time, but look at number 3. Yay or nay? What do you guys think? Thumbs up if you think it is, thumbs down if you think it's not. Look at the x values only. So if you got your thumbs up, you would be correct. It is a function. Our x values clearly do not repeat. It's okay if you have a negative version, a positive version of the same number, because they're technically not the same number, all right? But if it's the exact same number, meaning sign and all, nope. What about 4? Yay or nay? What do you guys think? That's definitely a yay. It's definitely a function. They're all different x values. So if I ever tell you to tell me if it's a function or not, that's what you're looking for. You're looking to see if the x values repeat. If they do, it's a function. If they, oh Lord, I'm not trying to confuse y'all. If they do, it's not a function. If they don't, it is. Now, the y values repeating, y values can repeat and it'll still be a function. We're going to talk about tomorrow a subtype of functions that is formed when the y values don't repeat. All right? But just know that if I just ask you whether it's a function or not, as long as the x's don't repeat, the answer is yes. All right? All right. Let's look at number 3. So we got everyone favorite thing ever, word problems. Although it's more so just kind of, do you understand what it's talking about? So let's break it down. Jenna is selling glasses and lemonade for $1.50 per cup. She begins her day with $4.50 in change, amount of money M. She has a function of the number of cups she sells, which is N equals 1.5 C plus 4.50. Which of the following would be an appropriate domain for the function? All right, so first things first, whenever we see any word problem, we're going to go ahead and figure out the important information. Someone raise their hand who has not talked today and tell me one piece of important information that we should probably know about. Intent to wink wink, it's probably where the numbers are. So I just want to know one piece. Again, there's no wrong answers. If you think it's important, it's important. Say again? Starts with $4.50. All right, so that's how much money she had in her box that she had when she started. All right, so she begins the day with $4.50. What else is important? The actual equation. So this is the function that models it. What else is important? What do you think is important? So if you think it's important, it's important. It's a word problem. Okay? So whatever you think is important. $1.50 per cup. All right? There's something else that I'm looking for. What else do you think is important? Right. So knowing what our variables mean. So amount of money M. That's what our Y value means in this case. And C is the cost or the number of cups. I think it states that note. Now, we're away from important information and now we're looking at what it wants us to find. Where would be where we look for that? How do we know what it wants us to find? What part of that entire statement would tell us what it wants us to find? Think about it. Typically, when it's asking you to find something, someone asks you a question. So we're looking within the question. So what does it want us to find? What does it say? An appropriate domain. So it wants to know what an appropriate domain for this function is. So in reality, we're doing no solving. We're just going through these and trying to figure out what an appropriate domain is. Now, that's a nice vocabulary word right there that you probably heard since Math 1, but you probably don't remember what it is, and that's okay. All right? Does anyone happen to remember what domain means? Close. Does have to deal with X and Y. It's just the X values. So domain refers to X values. So what X values of this function would work in terms of the problem. All right, so when we talk about domain, we talk about X values. Does anyone remember the word for the Y values? Starts with an R. Range, good. So domain is X values, range is Y values. Now, for that, we are going to look at this function. Given what we know about functions, where X is the input, Y is the output, and what we know about its typical placement, which variable here represents my X value? C. All right. C is actually within the function. All right. It's our input. That's what we're plugging in order to get the amount of money it costs. So C represents my X value. Now, in order to find an appropriate domain, we also need to determine what the X value is talking about in terms of the problem. So, given our important information, we know M is the amount of money, all right, that they have to give us, or that we now have in our box. What's C mean in terms of the problem? Think about what they're doing. So think about it this way. You're selling lemonade, all right? You're charging by the cup. You want to know how much money you have left in that box at the end of the day. How would you figure that out? The what? The number of cups you sell. You take how many of the number of cups you sell, multiply that by how much you sold it for, and add it to what you originally started with. All right? So that means our C means the number of cups sold. All right? So that's what you guys need to think about when you're tackling something like this. Okay? You need to think about what it means in terms of the problem. You're selling something. One of those values has to be the number that you actually sold. All right? So now think about this logically. Look at each one of these answer choices. If we're talking about the number of cups sold, does number one make sense? No. Why? Right. Can you sell a negative cup of lemonade? That's just air. I don't even know how you would figure that out. All right. So no, that doesn't work. So that's not an appropriate domain. What about two? What do you think? Could that work as an appropriate domain if we're talking about the number of cups? No. If you go to any business, they don't charge you for half a glass of something. They charge you for the whole glass, even if you only drink half the glass. All right? So that doesn't work. What about three? Could that work? Yeah. Why could three work? There's no decimals. What about this zero right here? Is that possible? Yeah, it's possible. Could there ever be a time when you're out there all day and you sell Jack Diddley? Yeah, it happens. All right. So this is our appropriate domain, but let's still check number 4. Would number 4 be appropriate? No. Why? Right. Same reason with number 2 isn't appropriate because of those 0.5s. All right. You can't sell half a glass of lemonade. At least not in America. They don't. All right. Or any country for that matter, I don't think. It's just not how capitalism works. All right. So, any questions about how you would break this down? So, whenever you hear the words appropriate domain, appropriate range, they're just asking what set of numbers could possibly fit into that variable and make sense. All right. Technically, if we plugged in every one of these numbers listed, it'd still give us an answer. But logically speaking, there's no way we have a negative glass of lemonade. There's no way we only have 1.5 glasses of lemonade because we're not charging by a half glass, we're charging by a whole glass. All right? So sometimes it's a matter of what logically makes sense, not just what mathematically makes sense. All right? Does that make sense? Any questions so far? All right, we got time for about one more. All right. So, all righty. Now we're looking at some graphs here. All right. So, what's asking us to do is, which of the following represents the range of the function of the graph below? So, we already talked about this. Range means what? The y values. So, domain meant x's, range means y's. So, essentially, what this question is asking, between what y values do we have graph? That's all that means. From this value to this, from this y value to this y value. There's a graph there, all right? Everywhere else, there's just empty space. That's all it's asking. Now, all of these ranges are in interval notation. You learned this back in math too. But let's just kind of review. So if you see parentheses, that typically goes with a what? So with set Miller notation, you have parentheses, you have brackets. Parentheses typically go with what on a graph? I'll give you a hint, some kind of circle. Look at this graph. There are two types of circles on here. All right, it's okay if you guys don't remember. So parentheses go with open circles. All right. So an open circle. And all that means is that it will get infinitesimally close to that number, but it'll never be exactly that number. All right. It never actually hits it. Even though it looks like it hits it. So for example, this open circle right here, it's at -4. All right. We're talking y values anyway. That means that this value gets so dang close to -4, it's just almost there. But it's not there. So that means you can have -3.9999999 going on forever in infinity, circle the world 3 times, a couple thousand times, circle the universe, still going to have a bunch of 9s, never going to actually be -4. That's what open circles mean. So what do you think a bracket means? Closed circle. And that means it hits it, it's exact, it actually is at that number at some point. There's no, we're almost there, we're so close to touching it, we can almost feel it. No. Slap it right in the face and hit it. All right? So if we're talking about range, that means that we're looking from the bottom to the top. So what you want to do is you're going to run your pencil from bottom to top. And you're going to find what your lowest y value is and what your highest y value is. So, what do you think my lowest y value is? Which is right here. It's at -4. So, that's the first part. Now, is that -4 at an open or closed circle? It's open, so that means it's going to be connected with a what? A parenthesis. So we're going to put a parenthesis next to it. Now, we're going to keep going. Now, there is a stopping point right here, but we still have a graph above it, so we're going to keep going. Because remember, y is going to repeat with functions. And we're going to keep going until we don't have any more graph. So what's that highest point right there? What's the y value? 5. 1, 2, 3, 4, 5. So, our highest y value is a 5. Now, is there an open or closed circle on that 5? It's closed. Rule of thumb, if there's not even a closed circle on there, but the graph is actually on it, it's technically closed. Only consider it open if there's physically an open circle there or an arrow there. All right? So this would be a bracket. So your answer for this is number 1. All right. Any questions on anything we talked about today? All right, so don't pack up just yet. We are going to continue this tomorrow. Your only assignment tonight is to get that sheet signed off for your syllabus. All right. So hold on to that packet. Make sure your calculators are put away, and do me a favor and put your name tags in the box for me. All right, so put your name tags in the turn-in box.